All right, everybody, hello and welcome back. Today what we're going to do is we're going to work on simplifying with radical properties. So now to introduce our radical properties, what we're going to do is we're going to start off with our exponent properties. So for the most part, you should be pretty familiar with exponent properties. However, we're going to focus on two in particular. We have the power of a product property. So it's basically when you have the product of two values and it is raised to a power. And then we have the power of a quotient property, which is when you have a quotient, so division, and then you have a value in that exponent. All right, so what this really means is we can take each of our values and we can essentially distribute in this exponent to both parts. Now, the reason we can do this is because we're multiplying in between, so we can distribute it in. All right, and the same idea is going to happen with our quotient rule. We are essentially going to distribute that exponent into both the numerator and the denominator. And that's going to allow us to simplify. So again, we have more exponent properties, but these are really the ones we'll focus on for the most part. All right, and that idea translates right into our radical properties. Now, we've realized recently that we can rewrite radicals as exponents, and that's why their properties work the same way. So, for example, if we are taking the square root of a times b, we can really rewrite that as the square root of a times the square root of b. And that's essentially this property here. All right, it's the exact same idea. The square root is like an exponent of 1/2. So if they both had that exponent, you could distribute it into each. So the square root of the product of two values means you can take the square root of each value and take the product. Now our quotient property is going to be essentially the same idea. If we've got the square root of a over b, that is going to be the same thing as the square root of a divided by the square root of b. And that's something we're going to look at over the next couple days. But again, same idea. A square root is like having an exponent of 1/2. So if both of these had an exponent of 1/2, you could distribute it into the numerator and denominator. So same idea, you could take that radical and distribute it into both the numerator and denominator. And that's going to help us simplify a little bit down the road. So what I want to do first is we're going to take the cube root of 64, x to the 6th, y to the 4th. All right, while we're doing this, I want to use that product property. And so what I'm going to do is I'm going to split this up into multiple radicals. I'm going to take the cube root of 64, the cube root of x to the 6th, and then the cube root of y to the 4th. Now, when we are thinking about the cube root of 64, I need to think of a perfect cube that multiplies into 64. All right, so for some of us, it might be a little bit difficult, but the way I try to think about it is, okay, let's pick a value and see if we can cube it and multiply into 64. So we might try to do 2 first. Now, we don't want to try 1 because 1 cubed is just 1 and that doesn't help us at all. We could do 2, and 2 to the first is 2, second is 4, and then the third is 8. 8 does multiply into 64. So we could break this up into the cube root of 8 times the cube root of 8. And the reason that is helpful for us is the cube root of 8. 8 can be written as 2 to the third. And when we have an exponent that has the same value as the radical, they cancel each other out. They're inverses of one another. And so we are left with 2 times 2, or 4. That is essentially the same thing we're going to do with our values. Now, because we got an even 4 out here, that tells us that the cube root of 64 is actually just 4. 4 times 4 is 16, times 4 is 64. But if we don't know that right away, that's totally fine. You can pick a cube root and start breaking it down from there, just like we would with a regular square root. Now, this idea for us is going to be very important when we are doing variables. What I'm going to do is I'm going to switch this over to a different color, and I am going to look for groups of 3. I can rewrite the cube root of x to the 6th as the cube root of x to the 3rd times the cube root of x to the third. And the reason that works is our product property means we multiply, and I would take those exponents and add them together. Well, as we just realized, when our exponent is the same value as the radical, we are going to cancel each other out. So these 3's cancel, and I'm left with just x and x. Well, x times x is x squared. So that's going to simplify even more. Now let's do the same thing with the cube root of y to the 4th. So if I try to split that up, I will get y to the 3rd times y. Well, really I should split that into 2 separate ones just to keep this consistent with my other values. And here we are. All right, so I'm using that product property to split it into 2 parts. And this one is going to allow me to simplify. Our radical 3, our cube root, and an exponent of 3 are going to cancel, and we're left with just y. But this isn't going to simplify, so I'm going to leave that the way that it is. Now this will also be part of my solution. My solution, the simplified version, is just going to be all of these values together. So we're going to have 4x squared y with the cube root of y left over. Now, this is a little bit easier when we break it up like this. It doesn't always work out that simply. So for example, the cube root of x to the 6th ended up leaving us with nothing left under the radical. Well, if we pretended this was x to the 7th, we just have another x value still inside that radical. We have 2 groups of 3 and an extra one. Well, what that means is this x would need to join the inside of that radical. So we would just have to keep in mind, sorry, that should be an x squared and then the cube root of x. What we're going to do is take all the values outside of my radical and put them together. And then all the values that are still inside would belong still inside our radical. All right, so for the most part, that is how I like to do this. I like to split it up. So we've got numbers, 1 variable, 2 variable, and then 3 and 4 if we have them. Okay? So we're going to keep going with the same idea, but this one looks a little bit different. And to be honest, it should be a little more simple for us. We are dealing with just numbers here, and we have the 4th root of 27 times the 4th root of 3. Well, hopefully we recognize that those radicals are the same. Whenever we're doing a simplifying problem, the idea is to always think about what stands out to us. What stands out to me here is that these radicals are the same. So I can use that product property we talked about up here. I have 2 separate ones. That means I can condense to 1 radical. So this is going to simplify to the 4th root of 27 times 3. Well, really, that's just the 4th root of 81, and now I want to simplify from there. So I got to think about what to the 4th power is going to give me 81. So think of values that multiply, that to the 4th power multiply into 81. So this is where it starts to get difficult because powers of 4 we're not that familiar with, and 81 is a little bit of a bigger number. Well, if we think about it, we can realize, hopefully, that 3 times 3, or 3 squared, is 9. 3 to the 3rd is 27. And then 3 to the 4th is 81. So the 4th root of 81 is simply 3. All right, so this one should be more simple than our value in the beginning, but we are using the exact same idea. Instead of breaking up, we're putting them together in order to simplify, in order to take the 4th root as we did in this problem. All right, let's keep going. So now we've got the 4th root of 80 times x to the 4th divided by the 4th root of 5y to the 6th. All right, now for the most part, we might look at this and again realize, hey, our radicals are the same. So what that means is we can put them under 1 radical. So we should have 80 x to the 4th over 5y to the 6th, all with 1 radical. All right, well, let's go ahead and simplify from there. We first look at our like terms. 80 divided by 5 is 16. We've got an x to the 4th and a y to the 6th. All right, so now we want to simplify a little bit more, and here's how we're going to do this. We have the 4th root of 16 times the 4th root of x to the 4th times the 4th root of y to the 6th. So what we're going to have to do is we got to remember that, first of all, this should be a -6. That's what puts it in our denominator here. And realistically, what we should do, and maybe this will be easier for us, is we should split it up into the 4th root of our numerator divided by the 4th root of our denominator. So what's going to happen is I can take the 4th root of 16 and I'm going to get 2. All right, so the 4th root of 16 is 2. The 4th root of x to the 4th, which I can do over here on the side, should leave us with just x. And then I'll switch back to green here. Our denominator, we need to think about groups of 4 and 6. And there's one group of 4 with 2 left over. So think about, we need 4 to get out of my radical. Well, there's one group of 4 plus 2 more in 6. All right, so technically this is where this problem leaves us. Now, this isn't very simplified because we still have another radical in our denominator, and as we're going to find out in the next couple of days, this isn't something we really want. So I tried to make this problem a little bit more complicated for us by adding some variables, and I might have made it a little bit too complicated. But here's what we're going to do. I am missing, in this case, I'm looking for a group of 4. I only have 2, so I'm missing 2 more. I'm going to do that to the top and to the bottom. Now, when I multiply across, in my numerator, I just get 2x times the 4th root of y to the 2nd all over. But now in the bottom, I'll have y and the 4th root of y to the 4th. Well, we just realized, or we just talked about this, this should cancel each other out. So we are really left with y times y, which allows us to no longer have a radical in our denominator. So our answer is going to be 2x times the 4th root of y squared all over y squared. And so we have something in the numerator and denominator that we would want to simplify, but because this is underneath the radical, we cannot. And therefore, this is the simplest we can get in radical form. So it got a little bit more complicated. The big idea that I want you guys to be able to take away is we can use that quotient property to combine, which allows us to simplify certain values. So in this case, we did the 80 over 5, and that was really just the initial problem without any variables, which eventually would simplify to 2, and it would work out pretty nicely. As I said, I tried to make it a little bit more complicated, and it got a little bit out of hand here, but this is a topic we're going to talk about a little bit later on. And so if you're not fully comfortable with it yet, that's totally fine. All right, I think we've got one more problem here. We have the cube root of 6 times the cube root of 72 divided by the cube root of 2. Lots of cube roots. Hopefully we realize, again, that we can separate that out. Because it goes to each value, we can really take 6 times 72 divided by 2. Maybe I'll do this in one step. So I can do it in my numerator first. So I have the cube root of 6 times 72 divided by the cube root of 2. Now, 6 times 72 is not really a good number for us. Let's see if we can do that real quick. We could multiply it out, but I'm just going to use my calculator. 72 times 6 is 432. So we have the cube root of 432 divided by the cube root of 2. Now again, we still have the same radical in our numerator and denominator, so hopefully we recognize we can simplify more. I can simplify to give us the cube root of, and I'm just going to make this into one fraction, 432 divided by 2, and that will simplify to the cube root of 250. 216. Now, we might try to see if there is a perfect cube that multiplies into 216. So let's just try a few numbers. So I'll take 216 and I'm going to divide by 8 first. The first perfect cube I can think of. And we get 27 and it worked. But that's an important value. So let's split this up. I've got the cube root of 8 times the cube root of 27. Well, the cube root of 8 is just 2, and the cube root of 27 is 3. 2 times 3 is 6. So this actually simplifies, which, looks like we've come a long way, to 6. Okay, so that is really all we're going to take a look at today. Your radical properties are essentially your exponent properties, so it works the same way. We can distribute it or pull it out when there's multiplication. If there's division, it goes to the numerator and denominator, and we really just want to simplify from there. The big part for us, I think, is going to be simplifying radicals that aren't square roots. When you have the cube root or fourth root, it does take a little bit more practice for us, but the ideas are exactly the same. In a cube root, we're looking for groups of 3, while a square root, we're looking for groups of 2. All right, if you have any questions, as always, please feel free to leave a question or comment below. Have a great day, and I'll see you all later.